Welcome to another training session on the PLC programming. In today's session, we will learn how we can use the PID Continuous Control function in the TIA portal. Let's see the setup for the today's tutorial. We have connected temperature transmitter with 4 to 20 milliamps output signal at the channel 0 of the S7300 PLC. And next we have a bulb which is operated by the SSR relay. This SSR relay have 4 to 20 milliamps input. This SSR is controlled by the analog output of the PLC channel 0 with 4 to 20 milliampere signal. As we have discussed analog input and analog output reading and scaling in the session number 12 and 13. In case you haven't seen these training sessions, the links are in the description box. We have placed the bulb near to the sensing end of the temperature sensor to warm up the sensor and raise the temperature. We will use the PID function to make a simple temperature controller. First of all, we will open the project file for the session number 13. As you can see that in the network number 1, we have a scale function to scale 4 to 20 milliampere signal of the temperature sensor. In the network number 2, we have an unscale function to send analog output 4 to 20 milliampere signal to the channel 0. In today's session, we will make the simple temperature controller with the PID Continuous Control function. We will double click on the Add New block and select the cyclic block OB35 and click on the OK button. This block executes after every 100 milliseconds. Next, we will go to the PID menu, PID basic functions and select Continuous Control function. As you can see that this instruction has too many inputs and outputs. Don't worry, we will explain all these step by step. First of all, we will enter M0.1 bit at the manual on input. This input will enable or disable the PID manual mode. When M0.1 bit turns on, it will bypass the auto PID output and send the manual PID output signal. Next, we will assign the bit M0.2 to the P select, I select and D select inputs. This will enable all three P, I and D controllers. If we want to disable any of these controllers, we can disable that controller. But in today's tutorial, we will enable all three controllers and hence we will keep M0.2 bit turned on always. Next, we will assign MD100 double word data register at the set point input. This input will be the set point temperature. Next, we will enter MD20 double word data register at the PV in. PV means the present value of the temperature. If we go back to the OB1, you can see that the MD20 data register is the scale temperature value coming out from the scale function. Next, we will enter the MD110 double word data register at the manual input. Whatever we write in this MD110 data register will be sent as the PID output signal if we enable the manual PID mode. Next, we will enter MD120 data register at the gain input. The value of the MD120 will be the gain input for the P controller. Next, we will enter the MD130 at the TI input. The value of the MD130 will be the input value for the integral controller. Next, we will enter MD140 double word data register at the TD input. The value of the MD40 will be the input for the D controller. Next, we will enter MD40 at the LMN output of the PID function. LMN is the output signal of the continuous control function. Whatever values the PID function will write in the MD40 will be sent to the analog output channel. If we go back to the OB1, you can see that the MD40 is the analog output signal for the scale function. Now the programming is done, we will upload the code in the PLC and monitor the ladder logic. We have forced on the M0.2 bit to enable all three P, I and D controllers. Next, we have to enter P, I and D values. We can set these values by trial and error method. I have tested the circuit before and found some suitable values for my circuit I will enter these values. First of all, I will enter 2.5 in the gain input, 500 millisecond in the integral input, and 10 millisecond in the D input. Next, we will enter the set point temperature. We will enter the 30 degrees set point. As you can see that the PID controller sends 100% output signal to the MD46 data register, and the bulb fully turns on and sensor starts to heat up as the temperature rises. Right now the set point temperature is 30 degrees and the current temperature is around 22.1 degrees, and the temperature is now slowly rising. As soon as the current temperature reaches the 30 degrees, the analog output of the PID function starts to decrease and try to keep the temperature around the set point 30 degrees. As you can see that now the temperature is maintained around the set point 30 degrees with 0.5 degree error. We can remove this error by fine tuning the PID parameters. That's the end of the today's tutorial. I hope you like it. Do share, like and subscribe to my channel and press the bell icon for more upcoming video tutorials. Till next time, take care and goodbye.